Hello, everyone. Hello to the virtual open day at the School of Computer Science at the University of Lincoln. Hello, Mark. Hello, Phil. How are you guys doing?
Hey, Oliver.
Yep, good, thanks.
All very good. Yes, it's a nice-ish day today at the University of Lincoln. It's a bit grey. It looks a bit like rain, but overall a nice day. It's still pretty warm. Before we continue, I'd like to introduce myself. If my slide says next, yep. My name is Oliver Simonisik. I'm a lecturer at the University of Lincoln at the School of Computer Science. I'm teaching game programming, physics simulation, game development. I'm also the admission tutor, so if you've got any questions about admission overall, you most likely already got in touch with me or exchanged a couple of emails or had a quick chat with me before. My background is, I've done a lot of programming in my life. My current interest is more programming, more development, and I've got an interest in digital board games, crowd simulation, crowd AI, and a lot of map stuff like indoor systems, indoor location systems. My contact email is down the screen, but I will put it later in the chat. It's ossymenyk@lincoln.ac.uk. Easy to remember. Yeah. I'll put it in the chat, no worry, guys.
Yeah.
Again, if you've got any questions or something you'd like to ask us, there's the chat feature on YouTube, so feel free to pop a question there or interact with your peers, and we'll answer the questions as early as possible. So feel free to use the YouTube chat system. Keep saying the YouTube because of a colleague saying the Facebook all the time. Anyway. So what we're going to do today during the virtual open day? Well, I'm doing the introduction, and we've got William Oldham, who is the school rep, going to do a tour of the Inb Building, the Isaac Newton building, which I'm currently sitting in. So Will is going to do that. Then the presentation of the building is followed by a presentation of Mark Doughty, who's going to introduce the program of computer science and talk to you about computer science at the School of Computer Science at the University of Lincoln, followed by Philip Carla, who's going to introduce games computing and talk about what's going to be taught in that program. All right, again, welcome at the University of Lincoln. I've got on the screen a picture that was captured last year of University of Lincoln in general, and it's a fantastic picture taken by a drone. And I'm currently sitting here in this particular building, the Inb Isaac Newton building, actually right there where my pointer is close to the door. And as you can see, that's the entire campus, actually a bit more than that. And it's pretty much central in Lincoln itself. Lincoln is a fantastic, beautiful city. There's a fantastic cathedral in the background. And there's a lovely little steep hill, fantastic high street. It is a quiet city, and it's actually lovely. I've been living here for 15 years and absolutely love living here. I really recommend at some point, if you haven't visited Lincoln yet, come to Lincoln, book a tour, have a look at our campus, have a look at the city, explore Lincoln. It's brilliant. Because Lincoln, even though it's not too far from a lot of larger places, you've got York, not too far, Leeds, Sheffield, Manchester, Nottingham, all within traveling distance, even by train, in about 2 hours' time. Again, it's a fantastic place. I mentioned the cathedral a few times, the Brayford Pool, the cathedral, the Endless Swans. Brilliant, fantastic city. Also, Lincoln is getting more and more attention in popular media, like in video games. For instance, there's a recent open world game set in the past where you can explore the historic the historic past of Vikings throughout Lincoln. It's a really, really nice game as well. There's an upcoming game, an RTS game, that will also explore the Viking past of Lincoln. And of course, there's more recent simulation game where you can fly over Lincoln itself. Again, it's explored in media. Have a look. Brilliant games as well. And I mentioned I'm currently sitting in the Inb Building. William Oldham is going to do a tour of it. Here's a couple of pictures that I've taken, for instance, of the upstairs lounge, one of the computer labs, and then second and third computer labs. Again, all will be broadcast live in a couple of minutes. And again, if you've got any questions, feel free to ask them in the chat. But again, don't be afraid to interact with us, to ask questions in the chat or to contact me over email. Also, there's other means to get in touch with us or to find more about the School of Computer Science. For instance, we've got a popular Twitter account that we're updating very regularly. We've got a Facebook account, a YouTube account, website. Of course, you're currently watching this on YouTube. Have a look around, have a look at all our social media presence. It's quite easy to find. Just search for School of Computer Science, Lincoln, and then you'll find us very, very easily. Also on our YouTube page, we've got plenty of talks up there. For instance, a couple of months ago, we did a British Science Week talks where people presented a lot of talks. For instance, we've got writing secure multiplayer games. We've got talks about shaders in Unity. We've got talks about cloud computing, about crowd AI. We've also done more talks on there, like Enhancement Week talks, where we welcome students to do their own talks as well. For instance, what is this thing called blockchain, robots in the wild, what is player experiences, board games modalities, and there's more and more and more. We've also got all the Open Days talks available on YouTube. So have a look at our previous Open Days talks and perhaps explore more of what our school can offer to you. I've got the link here at the bottom. However, though, since you're watching this on YouTube, just have a look at all the other videos that we've got on our channel. All right, so now I'm gonna pass it over to my colleagues. Will was sitting here, but I need to disconnect for a minute so I can't set up the camera and everything. So I'll be back in a minute, leaving you with Mark and Phil.
Thanks, Oliver. So yeah, if you've got any questions, obviously post them in chat anytime you feel like it. We're happy to answer any questions as we're going along. We'll try and get to them, in a reasonable amount of time. But if somebody's presenting, we'll definitely answer your questions at the end of each presentation. So Oliver's just going to move the camera around now. It's a bit tricky with the camera and the laptop and stuff. So we'll give him a few seconds. Interesting, Mark. I did have a look at setting up a 360 camera to do a live stream. Right. There's a bunch of different ones that we could get, but theoretically going to buy a reasonably good one soonish for the university and for us. So we should be able to do some live streams from the atrium at some point in 360. I wanted to get it so we could do some more camera work kind of stuff because I'm interested in that right now.
Right. And on cue, here's...
but sadly not yet.
He's
off again.
Not on cue.
Yeah,
so the School of Computer Science is...
Sorry, carry on.
No, I was just going to say that the School of Computer Science just runs two main programs, so the games computing side and the computer science side on the undergraduate degrees. But it's in a building that houses other schools as well, so engineering and math and physics. So there is a lot of crossover, there's a lot of sort of variation or whatever that you can add into your programs and whatever. So
that's a nice shot.
Yes. Hello, just quickly testing the camera.
Oh, I cut him off again. So yeah, we tried this live yesterday. We had a couple of problems with the USB stream not quite working, but that's all right. It's live.
It shows that it's live.
Yeah, exactly.
It shows that it's real.
But yeah, I mean, in general, the idea of these is that we're trying to give you a view of what the atrium's like, so we kind of want some of that to be streamed live.
Yeah, those are the problems of streaming live. Yep. All right. Is it working? Camera working?
Yep. Yeah, we see that.
Working. Yep. Fantastic. All right. So let's start. So I've got here my colleague, William Oldham, is going to introduce himself.
Yes. Hello, everybody. Welcome to the School of Computer Science. We'd just like to extend a very warm welcome to all of you watching us today. My name is Williams, and I am a third-year computer science student and also the school representative for the School of Computer Science. What that means is that I'm responsible for listening to feedback from all students across the school and using that to help shape the experience that you have at university. Alongside myself, I work with a team of course representatives who work closely with each year group in each course, whether that be games computing, computer science, or one of our postgraduate offerings. And all of that feedback we collate to make sure that you have the very best feedback, the very best experience, at university. So now we're just going to take you on a quick tour of our amazing Isaac Newton building, which is home for our engineering, maths, physics, and of course, computer science. So the first place we're going to go to is our lecture theatre. Now this lecture theatre will host over 500 people, and it's one of the primary lecture theatres that's not just used by us, but across the university for all of the large courses. So let's just hope that there's nobody in here. Looks like we're all good.
Oh, we lost connection.
I think we're breaking up a bit.
This is primarily where you will... Oh, back.
Sorry,
we're back.
Going.
Oh, we're good. Yeah, so this is where you will primarily have some of your lectures in computer science and also in games computing. And up on the boards there, we have 3 ginormous screens, so nobody misses out on any of the action that's going on, any of the slides, any of the presentations. And we also use this lecture theatre for some of our guest lectures that we have, both in the School of Computer Science and also more popularly in the School of Maths and Physics, where they bring in lots of external speakers, obviously in a bit more non-COVID times, and they will come in and present a range of different topics. So if you're ever near or about in Lincoln and you see one of these events going on, I really recommend visiting them because they're a really good way to experience the university and the academics that have come here. The next thing we'll go and look at is the atrium and the labs that we have.
So yeah, it's worth mentioning we get quite a lot of external people coming to the Inb Building, so it is really useful to take part in those kind of events. I mean, I've been to loads where it's just, an interesting sort of evening kind of thing.
And they're really useful, aren't they, for supplementing your course and broadening what you experience at university, I think.
Yeah, it tends to be the ones that are kind of left field, like biology professors and stuff, that I find quite interesting.
So you'll see over the balcony here, we have the atrium, and this is where any student across the university can come and work and eat. There's a cafe down there as well that's open in normal times as well. And so this is generally a nice working space to be in, as it's a nice communal working area that you can come and sit here with all your friends and whatnot across the course. Up on here, we have on showcase some of these arcade machines, and these are actually built by one of our lecturers. And the students can come and put games on these, and they can be played by anyone, and they're just generally a nice exhibit that we have. We have 2 of them here. And on our left, we have one of our smaller labs. Now this is a lab that's primarily used for master's students, and this has been newly outfitted with new computers, and there is currently across the summer going to be a large refurb of all of our computer laboratories, and so we're fitting brand new computers with 3070s and 3060s in them, which is going to become a wonderful resource for all of the students to be able to access. Traditionally, in non-COVID-19 times, these labs will be open 24/7, and so any student can come in and work on whatever project they need to, whatever assignment that they need to, and it's a fantastic resource for us to have at this university. I found it incredibly useful during my time here. And Oliver's just going to show off the wonderful RGB lighting that we have on our PC. So down here, we'll just show you one of the other labs that we've got. Is one of our other main labs, and it forms half of the bigger lab that you can see there in the background. And this lab is one of the main labs you would also come to if you're doing game development. This is primarily used as a game development lab. And so over the summer, a massive refurbish is going to take place that's going to completely change these and upgrade all these PCs. And it's going to make it become a lot better of an environment than it already is already. So we're really excited for all the progress that's going to happen over the summer. And the eagle-eyed of you over the shoulder will have spotted that we've got the massive crates of computers here in the background. So we've got an awful lot of computers here which are going to be redistributed for all of our 5 labs, I think it is, or whatever. And that's going to become the main resource for all of our computer science students to use 24/7 for all of their work that they're doing. And that concludes our talk. I hope you've enjoyed it.
Yep, thank you very much, Will. Thank you very much. Yeah, those are just a handful of the labs that we've got. As Will underlined, we've got a total of 5 labs, and those are just the 2 main ones that we'd like to showcase. And as Will said, the labs are going to be upgraded over summer. Oh, thank you very much. Yep. All right. Again, if you've got any questions or anything else, any feedback, just feel free to ask in the chat. If there's no more questions, I will hand it over to Mark Doughty, who's going to talk about computer science at the School of Computer Science. Yeah. Mark, are you ready?
Yep, I'm ready to go. Okay, so hello everyone again. Yeah, thanks for that tour. That was really interesting to see those labs, and needless to say, there's more labs so on different floors with things like networking hardware and so on. So this gives you a flavour of what we do in the school. So my name's Mark Doughty. I'm the programme leader for computer science. So I deal with all the academic side, the modules, the assessment, the things that you study, and so on. As a student, you'll also experience other tutors, so things like personal tutors, which will help you on the pastoral side and your life outside the university and non-academic matters as well. So, as Oliver said, we're based in the Inb, or the Isaac Newton Building. So this grey part of the building was added on and built only a few years ago to house mainly the School of Computer Science, but also the School of Maths and Physics. And that little yellow part of the building on the left-hand side is our School of Engineering. And it's situated sort of right in the heart of the campus, really. So there's been a lot more development since this picture was taken now. So you would have seen when Oliver and William started their presentation, in the background was the medical school, for instance, and that's been added since we've taken this. So why should you do computer science? So I guess some of you might be thinking, why do we need to do computer science? I'm undecided. I'm not entirely sure that I should do a subject like this. But one thing to remember is that computer science is probably one of the most fundamental disciplines really that govern the modern world. And what Steve Jobs says is applicable today as it was 20 odd years ago. So everybody needs to program. It teaches you how to think. So when you learn to program, You learn to think logically. You look at things like problem solving. You look at attacking problems in slightly different ways and trying to find novel solutions and so on. So it's a really useful thing, a really useful skill to have. Programming is only part of computer science, but it's a significant part. So again, why should you study computer science? Well, it contributes to our solutions to some of the major problems that we're facing in the world today. Things like pollution, climate change, poverty, health issues. All of those have elements, or all of those solutions to these, or potential solutions, have computer science elements to them. Whether it's computer vision, whether it's imaging from space, looking at where pollution is, look at whether it's simulation and graphical sort of implementations for things like climate change, whether it's looking at some sort of big data or statistical analysis of things like poverty and overcrowding and so on and so forth. There are many different ways that computer science can contribute, even in small ways, to solutions to these major problems. So the discipline of computer science is really useful to get to the heart of some of these issues. So what do we do at Lincoln that helps you to get involved and start to address some of these issues? So we do a number of different disciplines within computer science. So things like robotics, artificial intelligence, computer vision, machine learning, cloud development, as well as programming, software engineering, and so on. All of these sort of contribute to your development within computer science, but can also then be applied to some of these major problems. We also do different things as well. So cyber security, network security and management, games development, graphics and visualizations, AR, virtual reality, augmented reality, and so on, as well as many other things. So it's really then it can be down to you to choose to direct the course in the direction that you want it to go. So looking in a bit more detail about what you would study on a typical 3-year computer science degree here at Lincoln. So you'd start out the first year looking at some of the fundamental issues of computer science. So things like programming fundamentals, so that uses Python as the main language. So some of you may have experienced Python already. Mathematics for computer science. I know that many of you sort of think maths is a bit difficult or whatever, but this is very applied, and it's maths which will help you to develop as programmers and computer scientists. Problem solving is a very generic module, but also it sort of enables you to sort of start looking at problems in slightly different ways and attacking them in different ways and come up with solutions which may be slightly different, but also can help our understanding of the problem and its solution. We also start to study some of the more sort of focused elements of computer science in there. So things like object-oriented programming, algorithms, looking at the algorithms that make up solutions to problems and so on. In the second year, you start to look at things in a little bit more detail and a little bit more focused. So advanced programming, we'll start to look at programming using C++, for instance. We start to look at network fundamentals and management using our network hardware, database systems and cloud computing, looking at some of the more modern ways of storing and accessing data using a cloud and server-based systems and so on, AI and so on. And in the third year, this is when you can really start to influence how your degree starts to shape, really starts to direct your career. So there are some core modules that everybody does, so machine learning and big data, that we think should be part of a computer science degree, but you also get to choose your options. So there are 2 modules there that you can actually choose what you want to go in there. and we'll see those in a second. So alongside that is project. Now the third year is comprised of a big individual project, and that again can help you to guide your choice and your interest, if you like. So some of the options that you can choose in the third year, so things like graphics, looking at programming graphics, looking at VR and AR, for instance, and image processing, as well as things like robotics, cyber security, and so on. Some of the more theoretical sides of computer science, like logic and computation, and so on. All of those give you a sort of an ability to tune that degree to focus really on where you see yourself moving onwards after your degree and where your interests lie. So a typical week, again, this is typical. This isn't an actual week. It's a hypothetical week. So, for instance, you may experience a number of lectures, a number of workshops. So we tend to split our delivery into lectures and workshops, and we'll just explain what the difference is between those two in a second. Wednesday afternoon is normally reserved for things like sports clubs, societies, so your wider experience of university starts to become a lot more sort of rounded by societies, whether it's a related society like computer science, the Computer Science Society, or it's something completely different like, the kayaking or the mountaineering society, or a debating society. There are many others, too many to mention. Okay, so let's just look at the difference between lectures and workshops. So a lecture really is, so we saw William earlier in the main lecture theatre in the IMB. So a lecture is pretty much what you would experience in a class if you're at school or college. So the lecture can be face-to-face or online, but it's probably mainly face-to-face now. They're usually 1 to 2 hours in length, and they're usually for the lecturer or the academic to convey to you certain information or information that is required for that week in your module. These lectures are recorded, so that you can go back over them at any time in the future. The slides are also made available, so you can go over the slides and so on. It's also an opportunity for you then to speak to the lecturer, to also speak to your peers, and to start a discussion, ask questions, and so on. So it's a really useful opportunity there. The workshop, on the other hand, is for you to practice, for you to do things. So the workshop is in the labs that, again, William and Oliver showed you prior to this, and it's for you to practice what you've seen in the lecture. You're usually given workshop tasks to do, exercises, guided tasks. You're taken through certain things to enable you to practice and to put into action some of the things that you've seen in the lecture. You're usually timetabled into a lab, but also the lab, when it's free, is available for you to use pretty much all the time. In normal times, the labs are open 24 hours, but now obviously they're restricted, but hopefully that opening time will extend in the future. So what can you do while you study? So there are many different things that you can also do while you're studying here at the School of Computer Science. So you can follow industry certifications. So we offer Microsoft Azure-based, cloud-based certifications. So we provide the material and the ability to take the exam and so on. Also the CCNA, the networking certifications as well. There are a number of organised events which you can take part in, whether they're hackathons that are organised by the Computer Science Society, or more games themed. I'm sure Phil will talk about the Global Game Jam, for instance. But it's an opportunity for you to be with other people from your course, maybe in different years, but also people from other universities even, or other schools as well. There are too many to mention in terms of facilities. You saw a brief sort of a look at some of the facilities earlier, but alongside those machines, alongside those computer labs, there are lots and lots of hardware examples, things like Raspberry Pis, Arduino kits, VR headsets, mobile devices, whether it's phones, tablets, and so on, smartwatches, robots, robotic kits, and so on. A lot of these are used within the modules themselves, but also you can use as part of your individual project, for instance, to enable you to further your interests. In between your second and third year, what normally happens is you're able then to take on, if you want, you're able then to take on a 12-month placement. Over the last couple of years, these are some of the organisations where students have gone to do their 12-month placement, whether it's local, so things like the university itself, Brand Force, Siemens that are based in Lincoln, or whether it's more wider in the UK, so things like GE Aviation, Civil Service, and so on. All of those will help you study and also give you some clearer direction really on things like option choices and projects and so on. And we usually find that students that follow a placement are really in a good place in their third year for achievements and so on. Okay, so that's all from me really. So that gives you a brief flavour of computer science at the University of Lincoln. I'll try to answer some of the questions or all the questions that come through on the chat. But for now, I'll hand over to, I think it's Phil.
Yeah, that's right.
Who's going to talk to you about games computing. Phil.
Thanks, Mark. Yeah, so there's a couple of questions that actually came in already, so we might as well cover those before we get on. So Adrian asks about the research game arcades. They were part of a research study that I think it was talking about engagement for arcade machine control systems, if I remember rightly. They've basically got PCs inside them, so we can run pretty much any game that will run on the specification of PC. It tends to be that we've developed a number of, the students have developed a number of Unity-based games, and those were used to answer the research questions. So it was, at the time, it was a research project to understand how specific game mechanics worked. So that's what those machines were for. Basically, if you're interested in putting a game on the machines for people to play, you just need to speak to Chris, who's the actual sort of manager of those things. And that's the kind of thing that we'll have lots of different projects like that on the go at any one time. So, you'll often find hardware and software research questions being answered in the labs. And I'll talk about the game engines and stuff as we're going through the presentation, actually, if that's all right, because it is a big part of what I'm looking at now. So I'll share my screen. Hopefully everybody can see that. Right. Okay. So my name's Phil Carlisle, and I am the program leader for games computing. And I've been a professional game developer for more than 20 years. I don't want to say how long. And I've worked on a number of different games. The most recent one is a game called Ground Branch, which is being published by Microprose now, which is interesting. Previously to that, I guess the biggest sort of title I worked on was the Worms series, which did something like 17 million in sales. And I've spoken around the world, and I'm still interested in doing game development. I'm still doing research in this area. So what is games computing? Why would you want to study it? The best way I can answer that question is to say that it's basically the same kind of thing as computer science, right? It's applied computer science, particularly for the creative technology sector, which is mainly focused around games technologies. But I'll talk about why it's not just games as we're going through this presentation. But if you think of it as computer science with a games focus, that's the right way to think about it. We do a little bit of game design teaching, just so that everybody's got the basics of how game design is done as a process. But for the most part, we're interested in making really strong programmers. So if you come from the games computing degree and if you're a good student on that, you should be able to program anything. And that's what, like typical computer science, we need to be able to get you to be able to program things. So think of it as an applied programming course that's specifically for getting you a job as a games programmer. And what that entails is that a lot of this is about creating somebody who's capable of developing new technologies, new techniques, which means that you need to be able to analyze existing approaches, research new ones, and create actual implementations. So why would you study it? The one thing that I get a lot of, especially from parents, is why should my son or daughter study games? It's not a real industry kind of thing. And the reality is that for the UK sector, at least, games is the third biggest net income provider for the UK economy. So it's a really significant part of the creative industries sector, and that sector is a significant part of the UK economy. Technically speaking, games creates a huge amount of revenue, and obviously governments want to sort of support that. If we bunch games, like the creative industries and software in general, so ICT software and those kind of things, we are the second largest sector overall. So clearly, it's very important as a business to have people who are studying this, and it's actually a significant income for the UK. But why would you study games computing, especially? I mean, we are part of that creative industries thing, but what gives us the value? And there's some interesting things that have been happening relatively recently. So a lot of the bigger game engine companies, and we'll talk about sort of game engines as we're going along through this presentation, but some of the bigger game engine companies have actually started receiving really, really high valuations. So Epic, who do the Unreal Engine, they got valued at $17 billion relatively recently, and they got an investment partly funded by Sony, which was interesting, of about just under $2 billion for developing what they call the metaverse. But the point is that games technology is becoming much more mainstream, and I'll show you some of examples of that as we're going through. And similarly, interestingly enough, I saw a different valuation of Unity as this, but again, Unity, which is essentially the second competitor, a bit like Pepsi versus Coke kind of thing. Unity also got valued at 17 billion. I saw this one on VentureBeat that's valued at just under 14 billion. The point is they're both competing game technology vendors who have significant valuations now. And that's the thing that I think is important to realize. It's a big business. That's a multi-billion-dollar business now. So third slide, if you're not convinced by now, is that Microsoft, this is, I think, about a month old, maybe a little bit older than that. But Microsoft put out a press statement, again, on VentureBeat. And they were talking about how gaming as a proportion of like entertainment media was going up much faster than every other type of media. And if you can see here, things like music and actually books are doing all right, apparently. So, but music's going down, cinema's going down. Obviously, the pandemic's not helped there, but gaming's going up significantly. And from my personal experience, I can see that the games technology and gaming as a proportion of media is only going to keep increasing because people like the interactivity of it. So why would you study games computing? My biggest sort of, I suppose, sales pitch for this kind of thing is that it's just really interesting. I mean, I've been doing it most of my adult life now, And I still find new things to study about games, and I'm still really interested in, improving how we make them, improving our understanding of them. And that's what I want you to understand, is that there are lots of really interesting challenges in games, not just the technology, but the design, the understanding of how players perceive them. There's lots of really interesting problems to solve still. So what will you do if you study on a games computing degree? Well, for the most part, it is a practice-based discipline. You learn best by making things, and what we'll do is we'll give you lots of opportunity to develop games by yourself and with other people. So the idea is that you spend a lot of your time making games so that you learn the craft of making them, but you also, you develop your skill and experience. And it is this kind of thing where you just need to do it a lot. It's the application of the knowledge that we give you and actually creating things with that knowledge that embeds it in your practice. So it is a practice-based discipline. You'll be making a lot of games, and clearly that means that you'll be building a portfolio of games, which is what the industry really cares about at the end. But it's important to realize that creation of games is actually a broadly useful thing, right? So you can think of games computing as applied computer science, learning how to program things and learning how to design things. But that skill set is really very widely applicable. And so I'm going to talk you through some examples of why you might want to choose games as a program and how those skills can be applied in other industries. So here's an example from the Unreal Engine website. So this is the Epic Games website for Unreal Engine. And I took a screenshot of one of their little marketing bits just to show that their engine technology is being used in lots of different industries now. And I've looked at things like games and TV and film and automotive and broadcast events and simulations. And the point is that all of the skills that you learn are applicable across a broader range of creative technologies than you think. So things like TV companies are now hiring game engine programmers to support their live broadcast content. Companies like Fox are doing lots of interactive content with Unreal Engine, for instance. And that's not just Unreal Engine. So Unity have exactly the same kind of web page with the same kind of industries on them. And it's really interesting to sort of look at where these technologies are being applied. So we'll have a look at some examples. So just to sort of make you aware of this, there's quite a big change in the technology of these game engines that's happening right now, and it's still ongoing. So probably for the next year or two, we'll be seeing significant advances in things like resolutions and what have you. It's been kind of a bit stymied by the pandemic, but ultimately it is really very, very dynamic right now. And I really like that. So here's Unreal Engine 5. Again, this came out in early access probably about 5 or 6 weeks ago. And obviously it's not ready for prime time yet, but you can see that some of the technologies in the Unreal Engine 5 are clearly going to be adopted across the industry and across different industries, because the visual quality that you can get out of them is just so much better. So that's the kind of thing that I spend a lot of my time looking at, is where's the game industry going? I teach a graphics module, so it's kind of an interesting thing for me anyway. But ultimately, the direction of travel for games technologies is going in the direction that Unreal Engine 5 is signposting. So it's very, very early in that cycle, but we can see that games technology is changing again. So to give you an example of some industries that are using this games technology, if we think about Unreal Engine, one of the clearest examples for me is this on the set of The Mandalorian. So Disney decided early on in the production of Mandalorian that they were going to use the LED. They were basically going to use a thing called virtual production, which is a thing where you use a game engine to capture visuals, in this case on a set of LED walls, so you can see that there's that like curving background. And what that's doing is it's projecting an Unreal Engine scene using a number of different graphics cards onto that backdrop as a set of LED panels. And then what they're doing is they're capturing those LED panels in camera along with the live actors. And that means that they can basically save a huge number of a huge cost of shipping people out to the desert. And obviously, because it's a space-based sort of program, they can come up with like fascinating new ideas for where they can stage things. So basically, as long as they can produce it in 3D, they can film it. And you can see that this is causing a huge change in a lot of different industries. This idea of virtual production was very, very on the nail in terms of the pandemic, because obviously people couldn't go out to site. And so a lot of productions have moved to doing this. And I suspect that that will maintain across the film and TV industry for a long time. So that's a direction that we can see happening in creative technology. So what will you study while you're with us? And I want to sort of make this simple for you. You can obviously discuss different modules with me if you're interested in particular ones. But the way I see it is this. In year one, we're trying to get you to be a reasonable programmer. So we expect you not necessarily to be a programmer when you start the program. So that in the first year, you learn the fundamentals of programming. So basically, you will become a programmer, and we also give you some game design skills to go along with that. So we've kind of like, it's programming with a game focus, with a game sort of feel for it in the first year. And then in the second year, you become much more specific for games. So the idea here is that we give some group development modules as well, games production, but in games programming, what we're looking for is we specialize more in games. So you learn to program in the first year, you learn to program games in the second year. And it's much more about developing your understanding of things like game engines. And as we talked about sort of Unreal Engine and Unity, in the second year, you'll develop your own engine with Oliver and myself. And the idea is that you learn how to make the basics of a game engine. Realistically, you probably wouldn't do that anymore. You would be using Unreal Engine or Unity or another game engine. But you need to know how all of these things work. So we give you the opportunity to create your own. So the second year, you learn that sort of idea of how are games made, how are games specifically programmed. And then in the third year, this is the time when you get the option to choose your own path in terms of what you want to do in your, in your career. So the idea for the third year is that you choose your specialism. So for instance, if you're interested in graphics, you might do the graphics module and a project involving some kind of graphical effect. So the idea is that there's a number of core modules and then there's a number of optional ones. And the individual project, as it says, is basically something that you choose to do for your own specialism. So in a way, what we're saying is in the third year, you get to choose, you get to specialize. We give you some core competencies, but it's ultimately up to you to choose what you want to do in that. And that basically means that you then get a really great portfolio item at the end of it. So that's the general structure of how I like to think of the program. First year, learn to program. Second year, learn to program games. And third year, learn to specialize in the types of things you want to do in a career. So you obviously, for the option modules, you can choose a bunch of different options to suit what you're interested in. So things like if you're interested in VR and AR, you could choose that as an option. If you're interested in machine learning, that might be an option. So the point is that you get to specialize in your own interests in that third year. And obviously the individual project is similarly like that. So one of the big questions you should be asking is it the right program for me? And the way I would suggest you think about it is that game programming in general is very challenging. It isn't an easy program to do, but it is massively rewarding when you can do it. And the way I think of it is that with games, we get to create anything that we can imagine. So if we can imagine it and we can figure out how the technicalities of that works, we can create anything in our heads. And I think that's the real power of game development, is that we can create imaginary worlds that we can then, we can play in, we can live in. So it is a very challenging technical course, but it also is great fun. Obviously, you'll be working with other people who are the similarly creative. So there's a great buzz in terms of like when you actually create something really good in games, it tends to be that it's very motivational, right? When you see your products being played, you can really feel that enthusiasm increasing. So it does require that level of enthusiasm. It requires you to do lots of practice. It requires you to spend a lot of your sort of mental energy thinking about what you're doing. But then it does reward you because it is like really an interesting thing to do. So most of our games computing graduates, I think it was like 93 or 94% of our graduates get high-tech jobs at the end of it. And obviously, that could be with game studios. It could also be with lots and lots of different industries. And I would suggest that you sort of think about maybe not just working as a games developer, but working as maybe in an architect's office doing visualizations and those kind of things. So the reality is that the techniques that you learn on the program are available and used in lots of different areas now. So we can find employment in lots of different destinations, but they tend to be mostly technical in nature. So we do have placements, and I'll talk about those in a second. What I wanted to say is that we have got the Tef Gold Award, and this has become less of a thing since the pandemic. But the Tef Gold Award is the idea that when we were doing evaluations of teaching, obviously Lincoln was rated very high in terms of student satisfaction and overall sort of student the way that we teach was rated very highly by the I'm trying to think who actually was the awarding body, but basically it was the sort of university system gave us the highest award we could for teaching quality. So that was really useful. So in terms of placements, there's a guy called Sam who helps you get these kind of things, by the way, and we do obviously get employers approaching us asking for placement students and offering final year job offers actually as well. But Sam will help you with these kind of things. I will say that it is very competitive in nature in the games industry. The games industry tends to be a little bit worse than computer science in general for this kind of thing. But if you can get placements or internships, they're very highly prized. And some of our students have gone on to great careers by having placements at really prestigious games companies in the UK. I'm not going to mention specific ones because I haven't asked permission yet, but clearly we've got lots of people going into lots of great game studios right now. Internships are a little bit more rare, but they do happen. They tend to be shorter in nature, often summer internships, and they tend to be in playtest. So Rockstar's got a playtesting division in Lincoln, so they sometimes take interns and those kind of things. But the placement is probably a better option if you can find one, and we'll help you to do that. So Mark already mentioned things like extracurricular activities, and this is a really big part of what you should be thinking about while you're a student. It's not just about what you're doing on the program, it's about what you're doing extra to the program, what you're doing outside of the program to show that you're an interesting person. So we help the students to facilitate lots of different things. So game jams and hackathons are very common in computer science in general as a school. And we really want people to do those kind of things because they give you a chance in a short time frame to produce some really nice ideas. And if you get an idea that works well in a game jam, you can often make that into larger projects, and those are great for your portfolio. But again, a lot of these are student-led initiatives. So the Computer Science Society, the Game Society are all student-led societies. And that's a really important thing that we try and engender in our students, is that, you know, you can create your own societies. We do have some interesting ones that come and go, you know, as people come and start society up and then they leave. It's really interesting how dynamic it is. So it is really important that you understand that ultimately what we're asking for is for people to spend their time at the university being active and looking for things that interest them and working on their practice. So it's not just about what's on your program, it's about what you do while you're on the program. You know, like what do you do externally? Do you work with other people? Do you find a mod and work on a mod? All of those things really help you to increase your employability. So we will get to questions in a second. So Sarah's got a few questions. We will answer them. Just to make you aware, if you're interested in contacting me, you can see my email address here, pcarlisle@lincoln.ac.uk. You can contact myself or Olivia or Mark anytime you like to ask any questions you want. So feel free to do that. But we will get to your questions now. I'll just stop sharing my screen. Sarah asked, what language is used for games programming? Well, there's a variety of languages, actually, Sarah. So in the first year, I think we've settled on Python now. So Python and C#.
Yeah, Python and followed by C#. Yeah.
Yeah, right. So, and then in the second year, we do C++, and I think we still do C# in a couple of modules. And then in third year, we do quite a lot of C++. I'm trying to think if we still do any C# in third year. I don't think we do.
No, I think
so the games industry tends to do C++ as its main language. So we do quite a lot of that still. But to be honest, I've been talking to employers, and they, you know, some employers do things like JavaScript-based games, and some employers like doing it depends on the platform. So what I usually encourage students to think about is, don't get too enamored of one particular language or one particular game engine, for instance, because it could be that you want to get a job and the job is requiring a different game engine or a different language. So what you need to do is learn the skills of development, right? The processes that you go through and the practices that you use. And ultimately, those will work with any engine. So, you know, if you learn how to make the C++ side of a game engine, it shouldn't be just about the Unreal Engine, right? Because you might go and work for Ubisoft and they've got a proprietary engine. So you need to be a bit more flexible about that. But we do try and teach you all of the things that you need for, like, industry standard stuff. So things like Unreal Engine, Unity, etc. Oliver, you've got you can answer some of those other questions, I think.
Indeed, yes. Hello, Sarah. You're asking, do you give lower offers with EPQ? And it's easier to answer this question if you send me an email with all your details about your qualifications. But we do have different routes to accept people onto the program with different backgrounds, with different experiences, with different qualifications. So I recommend to you to contact me over email or to go through clearing. We will help you to identify what is the best route for you to get onto the computer science and games computing programs. I will put my contact detail and Phil and Mark's contact details in the chat. Does that answer your question? Hopefully, yes.
Yeah, just to go back to that question that Ariane had before, you know, about what engines and things we use. I've kind of tried to lay it out there that we try and basically use all of them, right? Because ultimately you need to learn to be flexible, and it could be that a new engine comes along and it's amazing and everybody switches to that one and you need to adapt quickly. And for the most part, game developers understand that if you're a flexible person that can work across different languages and different engines, that you're generally going to be much more employable because they know you can learn new things. It tends to be that the better programmers are the ones that can adapt to new technology quickly. So learning that as a skill is a very useful thing to do. Having said that, in terms of the actual sort of engines, so I tend to teach third year stuff. So most of my teaching right now is using either OpenGL in raw OpenGL, but most of it's an Unreal Engine now, because I'm doing some certifications and stuff for that as well. But ultimately, it's a mixture of different things, right? And you should try as many different tool sets as you can to figure out which ones you like working with. So I've used things like ZBrush. I mean, I'm not an artist by any stretch of the imagination, but I look at all of these different tool sets because it could be at some point I have to support somebody who uses those tool sets to make me content. So I have to understand how they work and figure out, how I make their lives easier. A lot of what a games programmer's job is actually making other people do work for them. So things like designers actually designing levels and me making tools for the designers to do that. And a lot of the time, it's about figuring out what are the best tools to use. So for instance, I'm using animation in Blender right now, but I've used 3ds Max a lot in the past. I know a lot of the artist friends that I talk to use a lot of Maya. And again, all of those are available to students, right? There's a student license for all of the Autodesk programs. So things like Mudbox and Maya and 3ds Max are all available to you. And I would encourage you to play with them as well. But we do teach things like Blender. We do teach Unity and Unreal Engine quite a lot. But I would encourage you to try all of it. Godot, making your own engine, all of it.
So Sarah also asks another question. Do you have support for students with dyslexia or autism? So the university as a whole has a strong disability and issue support system for students. With what the university calls a well-being centre. So students which are sort of which have these sort of conditions are able to get support from the university, and there's different types of support depending on the severity or the type of the condition and so on. So it's certainly at the forefront of the way that the university deals with students. So yeah, don't worry about that, Sarah. It'll all be explained to you once you get here.
Yeah, question by Pickle Chips about can students be taught engines or programs by lecturers out of academics? I'm not quite sure what that means, but I'm suspecting you mean, is there an opportunity to learn the engine outside of a module? If that's the question, then the answer is, yeah. In the past, I've run a few like evening workshops and stuff with a bunch of my students who were interested, and we made a little RTS game just on a Thursday night kind of thing as a bit of an extracurricular kind of thing. I'm actually going to be doing a series on Unreal Engine 5 because obviously Unreal Engine 5 is quite new, so there's lots of new little things to look at. So we'll probably be doing a series of videos on that, and it might be we do live streams involving those kind of things. The point is, it tends to be it depends to be whether we're interested in doing it or not, right? So I'm not saying that that's necessarily going to happen, but for the most part, we will do lots of different activities. And it's not just the lecturers, right? Individual students who've maybe got a lot more experience than others often do things like live streaming. And you can, the point is we're a community of developers. So you should try and think of it more as a community project. And do things like live stream yourself. I really encourage students to live stream their practice, because as you learn to be better programmers, you can actually teach other people who are just getting into it. And it helps you solidify your own understanding of things if you're trying to show other people how to do it. And I'm watching a guy from Australia who's doing lots of Blender-based animation for Unreal Engine right now. And it's just really good to see somebody else doing things, even if you kind of know how to do it already yourself. they'll often find little things that are just slightly faster to do. So I really recommend that you think about it that way. It's more of a practice thing than it is an individual being taught by one person, right? I like the name, by the way, Pickle Chips.
Pickle Chips, yes, I was thinking that too, yes, yeah. So thank you very much, Phil. Thank you very much, Mark. We're slowly heading towards the end of this virtual tour. So we've shown you quite a lot today. We've shown you the Inb Building. We've introduced our staff members. Phil has introduced himself as the program leader of games computing. He showed you all the content of games computing. Same for Mark. Mark Doughty, the program leader of computer science, showed you how computer science works, what the different modules are taught in first year, second year, third year. And we've hopefully given you a good feeling how the School of Computer Science works as a university. So thank you very much for attending. If you've got any more questions, I've put our contact details in the chat. If you're not so sure who to contact, just send me, Oliver Simonisik, an email, and I'll make sure that it is forwarded to the right staff. But anything games computing related, ask Phil. Anything computer science related, ask Mark. And again, feel free to have a look at our YouTube pages. For instance, Phil said there's a couple of things that you can do outside of the module, for instance, outside of academics. For instance, we've got a lot of lectures about, extracurricular activities on YouTube pages. Have a look at them. Have a look at our YouTube, at our Twitter pages, our Facebook pages, and other social media pages. Unless there's any more questions, I'd say that's it for today. Thank you very much for attending. Thank you very much for asking questions. We always love answering them. And again, thank you, Phil. Thank you, Mark. And thank you, Will, as well, who's actually not here at the moment. All right. So thank you very much. I'll see you around, guys. See you in October.
Thanks, everybody.
Bye.
Bye.
Bye now.